Hi everyone, so I'm back. This is 1.3 mixed and entire radicals. So what are mixed and entire radicals? Well, these would be kind of radicals wherein you will see a radical with a radicand, and then sometimes there's a number outside of the radical symbol, or everything would be inside the radical symbol. So before we go into that, let's take a look at the get started part. Here we go. Write each number as a product of the prime factors. Okay, 15. Well, what are prime factors? So prime factors would be those numbers that whose factors are only one in itself. All right. So for example, like 3, it's prime because the factors are 3 and 5. 5 would be 5 and 1. And for 15, it would be what? 15 would be equal to 3 times 5, right? That's about it. What about 180? 180, that would be 36 times 5, right? And that would be 6 squared times 5, right? Okay. What about 2,205? 2205. I think that's divisible by 5. That would be about what? If I divide by 4, yeah, by 5, that would be 441, right? 441 times 5, all right? And then that would be 21 squared times 5, all right? However, 21 is also 7 times 3, right? So that would be, it would be, okay, hold on. Let's rewrite this so that you could see it. Okay, 21 times 21 times 5, but then 21 is 7 times 3. 21, 7 times 3 gives you 3 squared times 7 squared times 5, right? Okay. Now if you're thinking, wait a minute, where did that come from? Remember 21, each of these 21s would be 3 times 7. 3 times 7, I just rearrange them. So this 3 squared is this and this. Well, this 7 squared would be this and this. Okay, next. The multiplication property of radicals is similar to the division property of radicals that was seen in the previous section. Now, this is sort of the inverse operation. Okay, all it's saying is this. If you have a radical and you have an index, right, and that radicand, the number inside, is the product of two numbers, A and B, what you can do is you can split up that radical into two radicals wherein the index would be the same as the original. And then there are now two radicals wherein one radical would have factor A, one radical would have factor B, and the two radicals are being multiplied right here. Now, if you're thinking, okay, can I see an example right here? For example, the root of 14 is equal to the root of 2 times 7, isn't it? So it can this one can actually be split up into two parts, wherein it's root of 2 times root of 7. Okay. What else? For example, root of 35. That would be root of 5 times 7. That would be root of 5 times 7. Root of 7. What about if it was a cube root? Well, same thing. Cube root of, I don't know, 105. It's the same, right? That would be the cube root of 35 times 3, right? And 35 times 3 is 7 times 5 times 3. And that would be the cube root of 7 times the cube root of 5 times the cube root of 3. All right, that's what it means. Okay. Let's take a look at the next one. Well, there are two radicals that we are going to look at in this section. One is called entire radicals. What these are, and if you take a look at this, what do you notice? They all have the radical symbol. The first two have square roots, the next two are cube roots, and they all have radicands, which are the numbers inside, but there's nothing outside of the radical symbol. Okay, when the radical is in this form, there is nothing outside of the radical symbol. There's no number, or sometimes said to be the coefficient. They are entire radicals. A mixed radical is when you have a number outside the radical. Okay, so there's only one example here because it's pretty obvious. 2 root 15 is a mixed radical because there's a number outside of the radical. All right, or in this case, if you're thinking, what about root 15? Well, that's just a mix. That's just an entire radical because there's no number in front. Okay. Okay, so let's take a look at what we're supposed to do. Page 23, writing an entire radical as a mixed radical using prime factors. Well, I'll do it on my own way. The prime factor idea, you just take a look at the book. All I'm saying is this. Right now, you have an entire radical. You will write it as a mixed radical, meaning see if you can rewrite this with a number in front. Right now, there's none. Right, there's only a sign, a negative sign. So what you're going to do is your trick or your strategy is to figure out whether you can factor this number into two numbers such that one of them has a square root. Okay, why is it that you have to find two numbers wherein one of them has a square root, so that when you split them up into two radicals, you will be able to get the square root of one of them? Take a look at what I'm going to do. 75 is what? 75 is 25 times 3, isn't it? Right? 25 being a nice number because 25 has a square root, which is 5. So I'm using the multiplication property of radical. As you can see, I'm splitting up the radical into two parts. And now you can have the square root of 25, which is 5. And there is your mixed radical. This is your entire radical. I turned it into a mixed radical with a number in front. You got it? Root of 42. Let's see. So again, try to turn it into an entire radical if possible. Or if turn it into a mixed radical if possible. Well, 42 would be what? 21 times 2, which is what? 3 times 7 times 2. Well, even if you split up all of those into its own radical, there's nothing that can happen. So not possible, right? It remains as an entire radical. All right, not possible to turn it into a mixed radical. What about cube root of 54? Well, the idea here is this. Instead of factoring 54 into two numbers wherein one has a square root, you will factor 54 into two numbers such that hopefully one will have a cube root. And some of you will say, Mr. Abrin, can I do 9 times 6? Yes, of course. But then they would not have a square root, right? However, if you do it this way, wait a minute, what if I write out 9 as 3 times 3, and then 6 as 3 times 2? Wait a minute, do you notice that this one would have a cube root? And there you go. The cube root of these 3 3's would be 3, all right? And there is your answer, isn't it? So another way to do this is this one. I will put an OR. So what you can do is you split it up into two parts again, and then find the cube root of one of them, 27 times 2. And then you will end up with cube root of 27 times cube root of 2. And then you have 3 cube root of 2, same answer. Okay. And that's it for check understanding number 1.